Hi, this instructional video is about graphing quadratic function. And, well, I wanted to show you this example because we had a little trouble in a class where we were learning about quadratic functions that are in three different forms. First, we all knew that there was a standard form written as ax squared plus bx plus c. That's the one where we identified the a, b, and c and the axis of symmetry and the vertex. And this was called a standard form. Okay? And then the second one we talked about was a vertex form, where it's a times the quantity of x minus h squared plus the k. Where the inverse of the h and also the k, they were the vertex. So this was called a vertex form. And the third one we discussed was called an intercept form, recognized as a times the quantity of x minus the p times the x minus the q, where the inverse of the p and inverse of the q, they represented the two x-axes, the intercepts that is, and this was called the intercept form. And then in class we're working on this particular problem, and when I asked the kids, well, what form does this look like? Well, one student pointed out it looks like, well, a vertex form. What appears to be an a coefficient and the middle term, and what's just missing was the k. And since there was nothing out here, the student said, well, that's the inverse of negative 3, 3, and there's no k, so it's 0. 3 and 0 is the vertex. It did not work. We were like, we were all going crazy. But then realized, there's something missing here. If in fact this was vertex, what was missing was the exponent. And by that, this is not a vertex form. In fact, it was an intercept form. So what you had to do was use the zero product property. Zero product property. So what that means is you take this term, coefficient or not, whatever it is with the x, you set that to 0 to find one of the x-intercepts. And then you take this binomial, set that to 0 to find its x-intercept. This one's easy. When you take the coefficient 5 over 2 and multiply the reciprocal to both sides, x is still 0. So that's one of the intercepts, the roots, the solution. Now this one, you add 3 to both sides of the equation, so x is equal to 3. That's the other part. Okay? So now when you graph, I don't have my ruler today, so I'm sorry. One of the intercept, the solution, or the x-intercept is 0. And the other intercept is 3. 1, 2, 3. To find the axis of symmetry, you have to count in from the two roots. 1, 1, half, half. Right there. That's the axis of symmetry. So x is equal to 3 over 2, or 1 and 1/2. Now, how do you find the vertex? To find the vertex, you have to take the original function, y is equal to 5 over 2x, and plug in the x, what we found as 3 over 2. 3 over 2 where the x that is, and we evaluate to find the y. That'll give us the x and y coordinate. There's nothing to simplify here, so we multiply across, we got 15 over 4. We have to evaluate these two numbers. The common denominator is 2, so we rewrite that as 3 over 2 minus, well, 3 times the denominator 2 is 6 over 2. So once again, we got 15 over 4 times the quotient of, well, here you get negative 3 over 2. Nothing to simplify here. So multiply across, you get 15 times negative 3 is negative 45. 4 times 2 is 8. So that's the y. Or you could say that it's going to be like negative 5 and 5/8. Almost negative 6, but not quite. Okay? So here's the x, and the y is negative 45 over 8. So let's count that down. So let's do this. It's going to be weird. Let me condense this. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. So negative 5/8 is somewhere over here. So the vertex is 3 over 2 and negative 45 over 8. Okay, so that answers the vertex. That answers the axis of symmetry. To find the y-intercept, well, let x equal 0. When you let x equal 0, you take the original function and set each of those into 0, and you'll find the y. You could see that, well, this whole thing here becomes a 0 times negative 3 is still 0. Okay? So in fact, the x-intercept also happens to be the y-intercept. There it is. Opens up because of the positive coefficient. There's the 2 roots. Which one of them happens to be a y-intercept as well? And I hope that answers the question from the homework assignment. Enjoy!